Perspective is important. How we look at things affects how we understand them. Changing our perspective can transform that understanding. Take living things. Normally, we see them as individual bodies, but by zooming in, we see new levels of detail. First organs, then cells, then individual molecules. At each level, we see that things are organized in stable networks, allowing our bodies to function reliably, day after day. Diseases arise from changes within cellular networks. When a cell becomes cancerous, these network changes affect how it grows, the way it spreads, the way it avoids the body's defenses. In developing drugs, science has traditionally taken a top-down approach, seeking a single master switch, trying to identify simple pathways through the diseased network that affect behaviors within the cell, and looking for drugs that will flip the switch related to those pathways. But this approach has many risks. Because we don't consider the whole of the diseased network, our drug may only affect part of it, allowing the disease to fall back on alternate paths. Or the drug may not be effective, because the pathway we chose is only part of a more complex network. The traditional approach has proved ever more challenging and costly. The rate of novel drug discovery is falling. Failure rates are still high. Simultaneously, we face new challenges as the world's population ages and grows. At e-Therapeutics, we take a unique, bottom-up perspective, embracing the complexity of biology and considering the whole network as we pursue network-driven drug discovery. We begin by modeling diseases as networks in silico, combining our unique biological insight with the tools of big data and AI, and real-world measurements from human tissue, allowing us to map the complete mechanism of each disease, rather than individual pathways or pure statistical representations. These models are analyzed using our proprietary techniques, combining biological insight with the latest innovations in network science analytics to identify weak points within the whole disease network, nodes whose disruption will have the greatest benefit, making it difficult or impossible for the disease to bypass. Next, we draw from our comprehensive library of active compounds and compare them to the identified weak points, seeking the compounds with maximum effect, allowing us to hugely narrow down the number to be tested in the laboratory and helping us find the most effective drugs. By embracing the true complexity of biology, we will find new and better drugs in a more effective and efficient way, treating unmet medical needs from cancers to neurodegenerative diseases. Through network-driven drug discovery, we can bring new treatments to market more swiftly and cost-effectively, and make patients better, faster. By changing our perspective, we can revolutionize the treatment of disease.